COBWEB is an acronym for Citizens Observatory Web, and what we're trying to do is to mobilise the most pervasive and widespread sensor network that exists in the world today, namely the citizens.
We responded to a European Union call for proposals, leveraging the massive increase in the availability of internet-capable, GPS-enabled smartphones and tablets in order to empower citizens to collect data for purposes of better environmental governance.
So COBWEB, I guess in essence, is trying to find technological ways whereby we can make it easy for people to collect data, whereby we can continue to sustain their engagement, and whereby they might actually get some collective return on their contribution to a corpus of data. So they might be able to see the collective data that was collected relating to the subject matter that they were contributing to. For example, the incidence of butterflies in a particular area, or the issue of our little bee community getting more and more threatened and compromised. So the number of bees that are spotted by a particular environmental group, or the incidence of something like an invasive species like Japanese knotweed. These are things that little groups are very often highly motivated to try and sort of contribute to the collective goal of addressing some of these problems.
We started out in COBWEB with 4 biosphere reserves that we're concentrating on. The thinking would be that we'd use these as test sites for developing the software in a co-design process with citizens in the biosphere reserves. One in the UK, in Wales, the Dovey Biosphere Reserve, and then we'd transfer the technology to Greece and Germany, and that would give a European dimension to the project, and we could see how successful we were with the concept we developed. We ended up having more than 1,000 volunteers over the field season in 2015 and 2016, collecting data, and they were continuously providing feedback through the conduits we'd set up in the project. So they'd say what works, what doesn't work. They helped us find some bugs, but more importantly, they made suggestions about how the software could be improved. So we were going through cycles of software refreshes and getting them to try out later versions of the software, and the software modified over time in response to their input.
There were 2 sort of work packages within COBWEB that were about interacting with our communities and the different user groups, the different beneficiaries and the people that could make use of the product. One of them was stakeholder engagement, and the other one was dissemination. The engagement side, which I headed up, was all about requirements gathering. So that was about understanding the potential use cases for the product.
I have been working on the portal, which is a metadata catalog for geospatial data, and where you can register, log in, create surveys, and then collect all the data using those surveys. First, there is a coordinator that has an idea about what kind of data they want to collect. So they register on the website, on the portal. They create a new survey, and they design how the mobile app will show which fields they want to collect, which data, which input, if they want to collect some numbers, text or photographs. And then once they have designed how the mobile app will look at, they can start telling people to join the survey. So they download the app, and they can go to the field, collect the data using that user interface the coordinator has designed, and then the data will be collected back to the server, where the survey coordinator can check the data, check that is correct, remove the data that is not valid, and do all the citizen science, the science part of the citizen science project.
We started by focusing on biological monitoring. We moved on to policy making, so some of the data that was gathered could really help the management body to rethink, to redesign several of their infrastructures.
We wanted to see not only the UNESCO managed biosphere reserves, but other sites that had a lot of ecological interest. What happens there, how it happens there, and what sort of challenges and opportunities they offer for research and collecting data. And it was a very nice experience because we went there with our students, we went there with high school students, we went there with different groups. Even a Welsh school came to Mount Olympus and visited, and it was a nice experience because not only we did what we normally do as a scientist, but we had the opportunity to interact with concerned and interested citizens and how these things work and what they do. Natura 2000 is based on two directives of the European Union, the Habitats and the Birds Directive. So this assessment has to be done every 6 years. It's a periodic obligation for every member state. So it was very happy that the results of the citizens were at least comparable, not exactly accurate, but comparable to the expert data. So that was a very interesting thing.
It's important to have open data just because all the science is building on open knowledge. Since the beginning of the ancient Greeks, if you don't share what you are discovering, what you are doing, then it's difficult that the science can advance. If you have the data, then you can compare to your own data, you can do different analysis that maybe the original researcher didn't realize he could do. So with open data, we can advance faster in science.
So we used in particular one standard which is called geography markup language. That is used to provide data that is first of all domain independent, and then we used another standard which is called COBWEB enablement. So that's a SWE and SWE for CS, and that is particularly used to provide sensor data, and we combined these two to provide a specific profile that allows to encode citizen science data.
The project has always had a strong standards focus. I mean, it's always been characterised by open data, open source software and open standards. But I think it's become particularly evident in the last few years, this very strong need to bridge the traditional geospatial standards with the increasingly prevalent semantic web standards that are enabling the next generation of the internet. Yeah, I think that's been a good research output from the project.
So technology readiness levels are one of the mechanisms we've used to assess COBWEB. You can have an idea about anything, but the gap between that and it being reality, being developed, being deployed, being ready with no bugs or problems with it can be quite huge. It's only when you get that user acceptance with the full functionality working, with the usability, the accessibility, the expectation levels of citizens certainly is enormous now in terms of their interaction with smartphones, their acceptance of whether apps work or don't work, whether they're ready to share data or not share data, who's trying to monetize that data or not monetize that data. There was a lot of work going on, talking to people, talking to organisations, to non-government organisations, to citizen groups, local groups and individuals about the sort of things they wanted. And then we use that to help design, but also then we use that to go back and test against as well.
We use standards from the ISO to qualify and give measures to the data we collected in COBWEB from producing bodies, authoritative data, etc. So qualifying only the data. In COBWEB, we also qualify the citizen itself, the volunteer, because somebody can systematically make lots of errors, and somebody can be very good, experts, non-experts, and things like that. But by accumulating the information that we get from comparing to other data sources and etc., bit by bit, we know the user, the volunteer.
We ran the whole exploitation work package, but there's two aspects to it. One is commercial, so how do we as an SME and the other SMEs on the project, how do we commercially exploit it, fit it into our existing business models, look at new business models, but the other part of the exploitation was non-commercial, so how could it be used for policy, how could it be used in academia, and also exploring things like social enterprises and how we might be able to exploit the results in different ways. We're really concluding that right now. We're coming towards the end of the project and spending a lot of time exploring all those options across Europe, but also globally, about how we can use that technology for environmental monitoring, for environmental policy, analysis, but also other applications around forestry and agriculture as well.
In Nottingham, we're going to pursue perfection of the quality assurance system for crowdsourcing observations, and we'll pursue this architecture and system development.
We are continuing this work even outside of COBWEB. We have set up a citizen science working group to discuss citizen science aspects, data profiles, services, and so on.
It is ultimately very useful and a useful source of data for supporting policy, which is obviously a great outcome for us and opens up a new source of evidence.
Increasingly appreciated in global change research that it shouldn't be top-down, it should be done collaboratively with end users.
Data is a very valuable thing, it is a very useful thing, but it's not the only thing. It is very, very important that this process increases environmental awareness and sensitivity of the people to what their actions have as impact to the natural systems.